content. And for each interface, both directions, there are data receiving direction and sending direction. This sentence we will encounter in the future in the study. We are in the NA stage. In addition to the VLAN we talked about today. When it comes to ACL in the future, there will be the same data. We have received direction as well as send direction. One might ask, does the full switch have VLAN? The full switch has a VLAN 1 by default. A switch for dummies is also a switch. The default port of the switch belongs to VLAN 1. It also has its own VLAN. But it's just that it can't be configured. You can't configure other VLANs for it, since the data sent by the PC does not carry the VLAN ID. Then the data is inside the switch. How can I forward it with an ID number? We are through the VLAN ID of the interface. So the default port of the switch belongs to 1. After the device is received, the tag is 1. Let's draw a picture to explain. This is a switch. A PC is connected below. PC now wants to send data. It is connected to an interface of the switch. I assign this interface of the switch to VLAN 10. And it is connected to PC. The connection terminal is access mode. Now access is going to receive data. When it receives data, there is a specification. First look at whether the data has a tag. If no tag, then I'll tag it. This tag is the current VLAN 10 tag. If a data is received, it has tag itself. Everyone will find it strange. I said to connect the terminal under the switch. And if access mode, computers or printers are connected under the switch, they should not be switches. How can I send tagged data to VLAN? This is also very simple. I will give you a simple example. For example, now this interface is connected to a PC or a virtualized server. Either now this PC or virtualized server. I opened a virtual switch for it. It is actually the same as a normal switch. If I now let it bridge the local NIC, then there is a switch here. If auto-negotiation is enabled on both ends, they can even auto-negotiate port. For example, this is an access interface. The data comes in with a tag. I let it bridge with the local network card. So finally there is a switch connected here. Then it can be sent with this tag. So there is also something called VLAN jumping attack. I open a virtual switch in the device. Negotiate with the above interface to become a trunk. This is VLAN 10. As long as VLAN 10 is allowed to pass through, its interface is a VLAN 20. It can skip VLAN restrictions and communicate with hosts below. It can all be done. But I haven't seen this thing in the project. In theory it is possible. I'm just giving you an example. PC can also send out tagged data. We are now because of the technology involved in virtualization. So many things are not so absolute. It is possible to receive tagged data. What if there is a tag? If you receive a tag with VLAN 10 now, then it receives and does nothing. That is, do not remove the tag. Any interface will never strip the tag in the receive direction, just to see whether to accept. If it belongs to other VLAN, then don't. If a VLAN 20 message is sent, it will not be accepted. This is a specification of it. Then let's draw. This data is sent now. Then tag it with VLAN 10. To be posted later. Send in our exchange. At some point it arrives at another interface. This interface is also VLAN 10. It is also an access mode. It is also connected to a PC under it. So what is its forwarding principle like? How does access operate when sending data? Very simple. When sending data, first look at the tag in this data. Is it the same as the tag of this interface? If this tag is consistent with the VLAN of this interface, should send, and will strip the tag before sending. If this tag is inconsistent with this interface, don't send. Here's how it works. So we see if it's consistent now. The data comes in and is tag 10. Walk in the switch with tag 10. Finally, we will query the MAC address table in the switch. And the MAC address table also has the VLAN to which the corresponding interface belongs. So I can locate this interface. And I found that this interface is also 10. Then it is now consistent with this interface. So strip the tag and send. What comes out is a complete blank data frame. It's a simple process. Finally, the data of the original frame is sent out. For two PCs. What they receive is neat. They feel like the two devices are connected like this. Data forwarding. So for the middle. All about VLANs they are unaware. We'll get to that later. A router is connected to the switch. For routers. If you connect to the router normally in the future. For example, this is a switch. This is also a switch. A router connected to the switch. Then the port of this switch should be access. Because the final docking is a layer 3 interface. Layer 3 interface does not know VLAN. So you have to make sure. This tag must be removed when the data is exported. If even a router. In fact, it can also be identified. But you have to turn on other functions. Next, let's see how to configure. This thing is not difficult. This is 3 devices. It is now on the same network segment. Let's see if the same network segment can't communicate today. They are both 10.1. We will configure the mask to be 24 bits later. They are all on the 10.0 network segment. But both of them are VLAN 10. It is VLAN 20. So wait a minute, we divide the VLAN. Divide on these 3 interfaces. After dividing it should be. Both of them can pass. But it doesn't work with both of them. Because originally if we did not do any configuration, all 3 of them should be able to pass. Because they are on the same network segment. The switch does not need to be configured. Learn automatically. Then it's straight through. But after we divide the VLAN, it doesn't work. Let's see how they can't work today. Okay. Let's do some simple configuration. When we talk about the trunk later. Another type. Let's demonstrate access first. Device boots up. This is PC1. Give it an IP address. 192.168.10.1. 24-bit mask. PC can be configured like this. Just enter 24 later. You can also configure the full mask with. Let's take a look at the complete mask of the next configuration. Then PC2. 192.168.10.2. We can also configure like this. 3, 255 and 10. This is also possible. Next. PC3 will not be configured first. Let's look at the switch first. We come in first. Everyone will find. Inside Cisco. When the switch comes in. No need to manually enter NO first. You may be a little uncomfortable. For switches. After changing the name. Let's check its VLAN.